breaking into Python in various ways. But yeah, I'd say types is a big one. That's an interesting question. What else is there? Okay. Now this is a distinctly unsexy topic, but something I should mention, which is interfaces and abstract classes. So in the last several lectures, we've seen how implements and extends can allow us to do interface inheritance and implementation inheritance. And as a reminder, interface inheritance is what you can do, and implementation inheritance is how you do it. Now, it turns out that in the modern era, interfaces, which originally were for interface inheritance only, in the modern era, they can have both abstract methods, that is just things that are semicoloned off, and default methods, which actually do something, right? They have a how. Now, I don't think I actually said this on a slide. I've definitely said it out loud. But in an interface, every method has to be public. So anytime I put public here, it was redundant, and we saw with IntelliJ, it yelled at us and said we don't have to. And another thing is that unless you use the keyword default, then the method is so-called abstract. So if it has a semicolon, it's abstract, meaning it doesn't actually do anything. It's just a thing you must be able to do. Okay? So there's actually one last thing I want to say about interfaces before we talk about their cousins, which is that you can also actually put variables inside of an interface. And in that case, there'll be public, static, final. So that means it's public and it's static. You know what those mean. And final just means you can never change the value. So you can use it for constants, like, say, gravity. And it turns out, by the way, that classes can implement multiple interfaces. So I can implement universe and illusion and make an illusory universe, let's say. It has to do all the things that universes and illusions can do, maybe get some default methods. So as we know, interfaces, you can instantiate them. They can either give you abstract methods or concrete methods. These are default methods. You can get public, static, final variables, and we can only have public methods. Okay? And they have to, and yeah. Now, there's actually a closely related idea known as an abstract class. We won't really use them much in this course. However, you may occasionally see them in the Java library, so I want to let you know what they are. So abstract classes are kind of in the middle between interface and class. So they cannot be instantiated. You can't say new list. Likewise, in Java, they have an example in their tutorial called a graphic object. You can't make a new graphic object. Now, abstract classes, while they can't be instantiated, they can do some things that interfaces cannot do. So just like interfaces, they can provide either abstract or concrete methods. So they can give you semicoloned off methods or actual methods. But the semantics are a little different. So it's just like kind of this keyword bloat thing where the language got a little more complicated than it should. But in abstract classes, by default, any method you specify as concrete, and anything that you want to say as abstract, you have to use the abstract keyword. Sorry, that's just the way it is. And so it's just the opposite of the default choice in an abstract class is concrete. You can also provide any kind of variables in any kind of method. So I can have, for example, public int xy, and that means every graphic object is going to get an x and a y that is public. Okay? And same thing with methods. You can provide any kind you want. You can have even private methods that get inherited. Okay? And just like we saw before, anytime you have an abstract method, if you have a concrete class, if it doesn't actually override something that's abstract, it yells at you. So for example, if graphic object provides a draw and a resize method, then the circle class absolutely must implement draw and resize. It doesn't need to implement move too. Why does it need to implement that? Because there's already an implementation. Good. It'll inherit that. Okay. So I'm going to use this. I don't know how visible it is. Oh, it is. It's even more visible there than on the screen. So this lighter blue will indicate an abstract class and a concrete class. So you can actually level this. You can actually have a hierarchy with an interface up top, an abstract class, and a concrete class. And so I've just thrown this at you here because probably hearing me talk about this might be a little boring. So I'll let you think about it and process what I've said recently. So in this case, I have a paper shredder interface, a deluxe model abstract class, and a specific concrete class not shown. And the question is, by the time we climb down the inheritance hierarchy, how many methods are left for DCX 9000? A copier I made up. How many does it have? take back over the room. There's some dissent. Okay. Let's talk about this interface. How many abstract methods does it provide? 2. How do you know they're abstract? It doesn't say abstract. Because that's what happens with interfaces if you don't say. Okay, good. So now we get to deluxe model. Okay, of these methods, how many abstract methods does it define? 1. This one, connect to Wi-Fi. Okay, so at this point, you would say there's 3 abstract methods. However, how many methods does this actually implement concretely? 1. Oh, actually 2. Count and shred all. Shred all was inherited from this one. So basically, this provided 2 abstract methods. This implemented one, but it added one again. So the ultimate answer is 2. There's 2 more that need to be done. Those are connect to Wi-Fi and shred. Okay? Yes? Here, why don't I have to say public abstract shred? So you don't have to explicitly say it because it's inherited from this interface. If you, in this class, do you not have to implement it? An abstract class does not have to implement interface methods. You don't even have to list it. And there's a chance I'm wrong, but I'm pretty sure I'm right. Okay. Yeah. We could try it, but I'm afraid to open it. Yes? So in this class, if I do public abstract void shred all, shred. That's a good question. So if I actually do public abstract void shred, like I just repeat this again, that's a great question. It would have no semantic impact, and I'm not sure what it'll do. I would open it in IntelliJ, but I don't have the files ready. I don't want to type all this stuff. So I'll table the question. But it's an interesting thing to ponder. What happens if you actually put this again in abstract class? Ultimately, though, there's 2 things that are left for you to do. You need to write connect to Wi-Fi, and you need to write shred. Shred all is already done. Okay? So to summarize this, that's as much as I'm really going to say about them. I'll give a little more. But for interfaces, the main goal is for interface inheritance, and you could do a little bit of implementation inheritance. And classes can implement multiple interfaces. With abstract classes, basically they can do anything an interface can do, but they have a little more capability, like they can provide non-public methods, for example. Subclasses, of course, also can only extend one abstract class, because there's a rule in Java that you can only extend one class. And in my opinion, whenever you're not really sure, you should use an interface. Abstract classes come up sometimes, but I feel like the more complicated the thing it is that you use in a language, the more likely you're going to cause yourself trouble. So you should restrict choices from yourself when you can. And Oracle has a whole tutorial on when to use each. This is not a software engineering class. We won't really see it in a lot of detail. But I do want to show you a little bit of why Java uses abstract classes. So this is how lists in Java work, but not totally, but this is mostly how it goes. So there's a list interface, and there's an abstract list abstract class, good name, and then there are 2 specific implementations that extend this class. What does abstract list do? Well, it provides, for example, an add method that adds something to the end of a list. How does it do that? It uses the add method and adds something to the end of the list. So it uses its own size method, and it uses the add method that's going to be implemented by these. So array list and linked lists, they're left. This is a method that's still abstract by the time we get to the bottom. Each of these classes has to be able to implement something for adding to any position in the list. But if you don't want to implement the add to the end of the list method, that's what add does. Okay? Now, one question you might ask yourself is, why isn't this just the default method in list? And I think the reason is that the interfaces didn't have default methods until 2 years ago. So that's probably why. Okay? And abstract list was public, and we can't just throw it away. So that's an example of something abstract lists were good for. Now, it's actually even a little more messy. This is more of what the real list hierarchy looks like. In reality, linked list extends abstract sequential list, and that actually extends abstract list, which extends abstract collection, which in turn implements collection. Okay? And if you want, you can browse the source code. We won't really care about this. But actually, I lied. This is the real, true hierarchy. Linked list, this is fun to try and lay out yesterday, by the way. It's just real weird. Like abstract collection, it implements list, but list also extends collection, and abstract collection extends collection. And, if you're excited about these things, you can read about them later. Okay. But I just wanted to let you know basically how abstract classes work, because you're likely to see them when you look at documentation. But you probably won't need to write any abstract classes yourself.